Today's lesson is 2.2, Parallel and Perpendicular Lines. In today's lesson, we're going to talk about if two lines are parallel to each other or if they're perpendicular to each other. To do this, we are going to identify their slopes. So the first thing that you need to do is find the slope of each line. Now remember, the easiest way to find the slope is to make sure that it is in slope-intercept form. That would be the form y equals mx plus b, where m, the number in m's place, is of course your slope. You're going to look at your two lines and you're going to ask yourself, are the signs the same? Your answer is either going to be yes or no. Yes, they're both positive. Yes, they're both negative. So over here I have plus and plus, or I have minus and minus, or I'm going to say no, plus and minus, or minus and plus. Okay, that's the difference between them. Oops, there we go. When I say yes, is it the exact same number? So they could both be positive or they could both be negative, but 2 and 2 are the same number. 2 and 3 are not. So we need to answer that question. Are they the same number? Yes, then we are parallel. No, then we're going to say maybe they're perpendicular. Maybe we made a mistake. Maybe they weren't the same sign. Okay, so I'm going to go check the perpendicular. All right, if I say no, they are not the same. Are they flipped upside down? Do we have something like, say, 2/3 and 3/2? Those would be flipped, right? The bottom becomes the top became the bottom. Yes, then they're probably perpendicular because they would have different signs. If the answer is no, then we're going to go back and we're going to check our parallel. Now, honestly, for these two, this is a question mark. So this one is like, are they? Let's go back and check, but it's probably going to be neither. In this case, it's going to be neither parallel nor perpendicular. Same thing here. I'm going to go back and check my parallel, right? I don't know, but more than likely, we're going to answer that it is neither. All right, let's go ahead and take a look at our first example. Find the slope of a line parallel to the given equation, y equals -5/2 x plus 2. So the thing we're looking for here is parallel. When we are parallel, we have the same slope. That's what that last graphic said. Let me go write it over here. Same slope. So let's go ahead and write y equals mx plus b underneath the equation. It is in the correct form, so all I have to do is look right here. There is my m. And so for my slope to be parallel, it would have to be -5/2, because that's what the last graphic said. It has to have the same slope. Let's find the slope of a line that is perpendicular to y equals -5/2 x plus 2. So once again, and my slope is of course the same, 5/2. All right, but when we are perpendicular, they are opposite reciprocals. Okay, this means, let me change this to a lighter pink or lighter purple. This means that their signs are opposite. One's positive and the other one is negative. Reciprocals means that we're going to flip over the slope. So we're going to take the slope and flip it over. So if we're perpendicular, let me go back. My slope for my perpendicular, it's going to change from negative to positive. The 2 is going to come to the top and the 5 is going to go to the bottom. These two are just going to switch spots. And there we go. There would be my answer. All right, let's look at example 2. Find the slope of a line parallel to y equals 7x minus 9. Once again, go ahead and identify the slope that you have. There it is, right there. M is always our slope. And since it's parallel, you can put the parallel lines. There we go. That is my answer. It's the same as the slope that we have. Because remember, parallel means same slope. All right, find the slope of a line perpendicular to y equals 7x minus 9. So once again, my slope is 7, but if I'm going to find my perpendicular slope, I have to do the opposite. So let's change the sign. It's positive, so let's change, it's positive 7, so let's change it to negative 7. And then let's do the reciprocal, which means I'm going to take my 7 and I'm going to flip it. Now remember, when 7, a whole number like 7, is a fraction, we just put it over 1. So I'm going to flip my fraction to be 1 over 7. There it is. There's my slope of my perpendicular line. All right, a very common question to ask is to give you 3 different lines, line 1, line 2, and line 3, and to ask you which ones are parallel and which ones are perpendicular. So we've got ahead, and we're going to compare lines 1 and 2, then we're going to compare line 1 and 3, and then last we're going to come back and compare line 2 and 3. Now, what I need to do is I need to go through each one of my lines and I need to find the slopes. I need to find the slope. So I'm going to go ahead and write y equals mx plus b underneath each one. Okay, that one's good. I have a problem with line 2. Line 2 is not in the proper form. Let me go ahead and write it. Do you see the problem right there? This is not y equals mx plus b. I've got to get rid of this 2 before I can actually say y equals mx plus b. So I'm going to go ahead and draw my line. And what I'm going to do, since there's multiplication hiding in between the 2 and the y, I'm going to go ahead and divide everybody by 2. Now I want to do this separately. I'm going to put it down here. I'm going to put a little 2 with it so I know that it's line 2. I want to do this separately, right? I want to do it separately because I want to make sure I know which one of these two numbers is my slope. If I put the division of negative 3 by 2 in my calculator, it stays the fraction negative 3 over 2x, and same with 7 divided by 2, it stays as 7 divided by 2. All right, now I'm in the proper form. And I know what my slope is. I know what my slope is. All right, and the last one, line 3, once again, can't do it. So I'm going to have to draw my line. Now this one is a little bit more tricky. Notice that the y, it still has the times, but there's also this plus here. I have to get rid of the plus first because I have to follow the last 2 steps of solving an equation whenever I solve for a variable like y. So I'm going to have to move the 4x to the other side by doing the opposite sign of it. It was positive, so I'm going to go ahead and make it negative. And bring down my 6y. Now, we can write 4 minus 4x. We cannot subtract them. We cannot say 4 minus 4 is 0, so we have 0x. The first 4 on top, this one right here, it does not have an x, so I cannot actually subtract 4x from it. But I'm going to write it in this form. because of y equals mx plus b, okay? I got to get rid of the 6, and so just like in the previous one in line 2, I'm going to go ahead and divide everybody by 6. Now this time, when I divide -4 by 6 in my calculator, it is going to reduce to the fraction -2 over 3, and 4 over 6 will reduce to the fraction 2 over 3 as well, 2/3. All right, now I am in the form y equals mx plus b. All right, I'm going to go through and I'm going to start looking at my slopes. So I just want to identify my slopes. And I'm going to grab my highlighter to do so. So my slope here would be that. My slope here would be this. And my slope here would be that. Remember, x is identifying the slope, but it's the number itself that is the slope. X just helps me identify it. So x is technically not part of the slope, but it's an identifier to what the slope is. All right, let's take a look at lines 1 and 2. Take a look at your slopes, 1 and 2. Do they have the same sign? Negative, negative. Yes, they do. Take a good look at the number. Are they exactly the same? 3 on the top? Yep. 2 on the bottom? Yep. That makes these two lines parallel. These two are parallel. All right, now let's go ahead and take a look at lines 1 and line 3. Let's take a look at this slope and this slope. Are they the same sign? Yes, they are. Yes, they are. Are they the exact same number? Well, let's take a look. Let's take a look again. 3 on the top, 3 on the bottom. Nope, they're not parallel. So I'm going to go ahead and cross out parallel because they can't be that. Let's check for perpendicular because they seem to have done the flip, right? 3 on the top, 3 on the bottom, 2 on the bottom, 2 on the top. They seem to have done the flip. So are they perpendicular? If we go back and look at the graphic, and I'm going to slide back for just a second, for them to be perpendicular, they cannot be the same sign. They have to be the opposite sign. So let's go back and look. Negative, negative. That's the same. They are not perpendicular, which means they are neither. They are neither to each other. Yes, they flipped, but they have the same sign, not perpendicular, not perpendicular. All right, let's take a look at the last ones, line 2 and line 3. So here we go, line 2, line 3. Well, they are the same sign. So I'm thinking parallel, right? I'm thinking parallel, but I have to check to make sure they are the exact same number. 3 on the top, 3 on the bottom. No, they are not parallel. See how much time this is taking me to go through, guys? Don't rush it. You really have to stop and you really have to ask yourself these questions. All right, so now I'm thinking, per my graphic on the first page, maybe they are perpendicular. So let's take a look. 3 on the top, 3 on the bottom, 2 on the bottom, 2 on the top. That's flipped. They have flipped. But remember, they must be opposite signs, and they're not. So we are not perpendicular once again, which means we are going to be neither. All right. When you are given 2 points, x1, y1, and x2, y2, the formula for the slope is thus. m equals y2 minus y1 over x2 minus x1. We're going to go ahead and in this last example, we are going to find the slope of a line that passes through the given points. The first thing you want to do is make sure that you label your two given ordered pairs. So for my first one, line 1 goes through negative 3, 8. Remember, the first number is always x and the second number is always y. Since this is the first point, it's very common to call them the ones, x1, y1. We never mix the numbers, but we always mix the letters. And the 0, 4. So once again, x, y, and this is my second point. To find my slope, I'm going to do y2 minus y1. And remember, you can go ahead and cancel them out once you've used them. x2 minus x1. Now 4 minus 8 is going to give me negative 4. And 0 minus a minus 3, well, that's going to change to a plus, which is going to give me 3. I'm going to check that in the calculator, but that will be my ending slope, negative 4/3. Let's take a look at another one. Line 2 passes through the point 4, 4, so x1, y1, because these are the first x and y's that I see, and negative 4, positive 2, x2, y2. Every single time. Don't ever call them x and x, y and y. Make sure they're x and y, x and y. All right, let's go ahead and plug it in. Remember, in the numerator of our fraction for our slope, we're going to subtract our y's. We're going to do y2 minus y1. So I just came over here, y2 minus y1. There we go. And then on the bottom, I'm going to do x2 minus x1. x2 minus x1. All right, so 2 minus 4 would be negative 2, and negative 4 minus 4 would be negative 8. When I go ahead and divide this, a negative divided by a negative is going to be turned into a positive, and 2 over 8 would reduce to 1/4. There's my final slope. All right, one last time. Line 3 passes through the point 4, 1. Remember, x1, y1, and 8, 4, x2, y2. Let's go ahead and find the slope. Remember, I'm going to subtract the y's on the top. 2 minus 1, y2 minus y1. And on the bottom, the x is in the same order. x2 minus x1. x2 minus x1. I would like to show you one other pattern that the slope has. Take a look right here. This is this ordered pair. I've taken the ordered pair and I've made it into a fraction. I just have to remember that this one is the numerator and this one is the denominator. I always take this fraction and write it like this slope and write it, this point and write it like this as a fraction. Likewise, right here, I'm going to take this point and write it as a fraction y over x every single time. That's another way that you can think of doing the slope. 4 minus 1 is, of course, 3. 8 minus 4 is 4. And so 3 divided by 4 would stay the fraction 3